can see I'll get a clearly positive response as well as the data. So now again I switch back to drive mode, then I'll send this data, then I'll get a 2, then drive mode. Then I'll switch back to parking mode and then I'll send the data, I'll get a parking mode, and you can see the value will be parking. Then I'll switch to neutral, then I'll send this data, then I'll get a neutral, the same thing. Hello everyone, welcome to Embedded Electronics Academy. This is Automotive Embedded System Part 6 English version actually. So we have a part 5 previously. In that we discuss about the UDS service 10 with hands-on and demo. So here also which we are going to discuss about service 22 with a demo. So this is the new upgrade which the Embedded Electronics Academy did it. So in the previous demo, in the previous part, you can see only one simulator, tester simulator, that will only handling the request and response. Now we have one more simulator. This is actually the ECU simulator. So both will be handled how the real system will work. The same way this will replicate. So how the real system will communicate a CAN channel, the data exchange between the basically the CAN channel, but here we are exchanging data in the file systems. So there is some information written into the file, the same information which read by the another simulator via file systems actually. Yeah, but if you see in the overall picture as a demo, it will be look like how real ECU will work. The same method will be there. Yeah, I hope you guys will like this demo as well as the way I've organized the information. Yeah, without any further delay, we'll go the detailed discussion. Yeah, today the service 22, the basic idea, what is service 22? We'll just have a recap on that. As I mentioned, most of the people might seen lot of videos in YouTube in UDS AUTOSAR. So I will not put more information on this area. I will just have a small information I will put it, then our focus fully on in demo point of view. Yeah, the service 22 with NRC, yeah, then there is a requirement which is I created for this demo purpose. With that we will discuss it, then the demo. Yeah. Yeah, UDS Service 22, you guys already aware of what is the purpose of this one. I'll just recap this. Basically, Service 22, it's used to read data by identifier. So there is a service ID followed by 2 bytes of DIT. If you send it to the ECU, you will get a response according to the DIT, what is configured in that DIT. So it's basically we are reading the data element like sensor data, system data, as well as configuration data. So these are the data which we are getting from the ECUs, as well as these informations basically stored in the NVM, and then that value we are retrieving it, as well as some value will be written into the RAM as well. So if you see, there is a basic frame format which we saw in last service as well. So here also we are going to see how the basic how the frame format will be look like in 22 service. So if I send then first will be 03, there is a data length. That means there are 3 bytes of data going to it will be going to we are going to send it to the ECU. So then the followed by the data length will be the 22, the service ID, that is what we are discussing it. Then another 2 bytes will be the DIT. Basically in this DIT there are some specific functionality which might be implemented in the project, that information we get it. In this example which we are going to talking about the gear example, for example this is the automatic transmission gears. So if I put a gear as a neutral, what value? If I put a gear as a drive, what value will get it? So remaining bytes I don't consider because this will be only 3 bytes of data I'm going to handle it. But the transport layer I'll always give as 8, but in this application data I will give only 3. And now I'll get a response as a 4 because 4 means there are 4 bytes of data is going to receive from the CCU. 62, it's obviously a positive response, 62. Then the DIT, then followed by the data. So this is what I explained it. So there is a gear position. According to that, the data will come. For example, if I put a gear as a drive position, then what value, and then neutral position and what value. The same example will be available in a demo. Yeah. Yeah, before the demo, there is again one more small recap on NRCs. This is the flow of NRC. In my complete learning series, the NRC I will going to maintain in such a way only. like a mandatory, optional, as well as a supplier. So for now, for 22 surveys, these are the mandatory NRCs available right now. So 13, 33, 31, 78, 14. 13 as usual, it's a length. 33 is a security access, and then a request out of range, and then a response pending. And 14. 78 and 14 are similar, both are similar functionality basically. So we will see one by one. So here 33, it's for security service. Why I mentioned 33? Some DAD can be hold the confidential data. For example, as I mentioned, key values, some software version numbers, software parameter values. So for that, we should clear first security, then we should enter into the then we can send a request, then we will get a data, and then as well as condition not correct. These are the frame for analysis. For this demo, we are going to only see uh, NRC 13, NRC 31. Why? Because 33, 78 are I need some time to implement the logic in the tool. So probably I will implement soon. In the next update, this will be available for you guys. Yeah, next week. Live requirement. This is a requirement I have created for our demo. There are two requirements. One will be the gear position, one is a coolant temperature, and then gear position have some DAD number and coolant temperature also DAD number, and then what are the analysis which will be supported in session. These are the basic requirement which I created for this experiment. Next we'll switch to the demo. Yeah, this is the tool which I created for our demo basically. The left hand side, you guys already seen this tool in previous video. This is just some GUI update. Previously it's not look like this, it will be something different. Now there is a small update in the GUI, but the functionality is same, as well as there is a one more add-on functionality tester present I have added. Why? Because we are going to deal with the 27 services. In that time the session should be alive, so that's the reason I have added this will come in the next part. And then if you see my right hand side, this is the ECU simulator. So there are two parameter will be this ECU will be going to handle it. One will be the temperature, coolant temperature. The information of coolant temperature will transfer via this can, and then the information of the gear position will transfer via the can. I have configured the two can IDs, 10 and 20, 200, sorry, 100 and 200, and then the DLC length and respective cycle time. So I can start the simulation. So if I start it, it will be equivalent to the engine start or the power on cycle. So now the messages are going into the device in the bus for higher level, and this message will be taken care in the file system for the handling of the diagnostic side. Yeah. Now you can see there are two messages going in this. Let me stop the first one to get, you should not confuse it, should not mess. So now this is the gear message information. Now I put a parking, so that's the reason the value is a 1. Now I can switch to the drive position. Now the gear value is a 2. Then I can switch to the reverse position. Then gear value will be 3. So as we mentioned, we have a DAD called 1414. This is the DAD which we are going to use for read the live data basically. So yeah, this is the one. Yeah, now I can type. This is the ID I already configured 65 and then 8 the DLC length. Then data will be 03. Yeah, then 22, then 14 14. Yeah, this is the DAD. So if I send it, maybe before that, let me clear the trace as well. You will get some more data detail. Yeah, now I can send the request and you can see I'll get a clearly positive response as well as the data. So now again I switch back to drive mode, then I'll send this data, then I'll get a 2, then drive mode, then I'll switch back to parking mode and then I'll send the data, I'll get a parking mode, and you can see the value will be parking. Then I'll switch to neutral, then I'll send this data, then I'll get a neutral, the same thing. So yeah, same, everything will be same. Now we can see the negative response, we can see the NRC for this services. So as usual, same, let me clear this one. So now I can just put it as a 2. So I am expecting the NRC 13. Yeah, I'm getting NRC 13. because the software is expecting 3 bytes of data, but we are sending only 2 bytes of data. So that's the reason it is throwing the error as a 13. Now again I can recover this error. Now I send this data, so I'll get a parking data. Yeah. Now next requirement we can see, let me enable this message as well, so you can see the both the messages are going it. Our next ID is 14. It's basically talking about the coolant temperature. You can see 1412. So this is what we are going to discuss it. So I can stop this the gear usage because it will get confused. We cannot see properly. Yeah. Now there are messages 19 degrees Celsius is going in. Now I'll change the DAD to 12. Now I'll send a request. So you can see the temperature is reading on the diagnostics 1963, as well as the raw data which is in the CAN bus, same data is coming here. Now let me increase the temperature value. Now I'll send it. Yeah, you can see there is a difference. 55 DC, 55 DC equivalent temperature raw value, physical value. There is a raw to physical conversion is available, that we will discuss in later. Now we just discuss how it is going and coming. We can see. Yeah. Now I'm again increase the temperature. Then I can see there is a change in temperature, and then I can put the maximum range. Then yeah, I can put the maximum range. I will get it. Yeah, that's what. This is the way basically we will tune and verify and read our dates ECU parameter. Yeah, now the same approach we'll do for NRC. Yeah, 13 for DAD service 22. Now I'll send this. Yeah, I'll get the same perfect response. I'll get it. Yeah, this is fine. Now what I'm going to do it, I'll going to do make the a request out of range NRC. Let me put the number 1515. This DAD I didn't implement it in my software, I think in this Python background. So if I send this request, I'll get an RC 131. So now already have a failure. Now I'll make a set 2. That means I am going to make a sending only 2 bytes of data. So there are 2 NRCs available over here. Now I should expect 13. Yes, I'm getting 13 because 13 is the highest priority. So I'm getting this 13. Yeah. Now let me recover this one more time. Then I'll get a 31. Yes, perfectly I'm getting 31. Now let me change the value 14. Yeah, I'll get a same response. Yeah guys, that's all. This is the demo for our 22 service with the live message and can console how it is working on it. Yeah, we'll go and see the next demo. We'll see you there. Yeah, this is the one other demo I just want to show you. In the during my last video, the part 5, I'm discussing about the service 10. In that, there is one more NRC called service condition not correct. I explained it, but I could not able to demonstrate it due to the tool update. That time tool was not ready. Now the tool is ready, so I can able to show you how the condition not correct will support for your 10 service. So I already added the data over here, and then I'll send the request. Yeah, as usual I'll get a response. And then before that I have add one more point. I present the tester present. So yeah, there is a service called 3E that will be always live in our session. So if I disable the tester present, there is a timer, it is reducing, you can see. Now again I enable the tester present, the cycle timer will become 5, the same data. Yeah, now I have a proper session I can going. Now if I want to make a condition not correct, now in this project, in that ECU, I have a put a gear position normal, neutral and parking. Then there is no any problem. Other than this, then I cannot enter to the session. So now for example, now I put a drive mode. You can see it's a drive, and then there is a signal also get updated. If you want to verify, let me verify with the 22 service as well. 22, yeah, 22, then 14. This is our request. So you can see, yeah, the drive position, and this is the one. Now let me clear it to, then let me put it as a 10. Then let me give a extend the session. Let give this. So if I send this, you can see, yeah, condition not correct because my gear is drive position. So the ECU will not allow the transition. So I'll get this NRC. Now let me put it as a normal, like a neutral or parking. Now I'll send it. Yeah, I'll get the response. Yeah, that's all, guys. This is the way of checking the condition not correct. According to the project, they will make some condition. With the condition, if it is satisfied, then they will allow. Otherwise, they will not allow. Maybe now this is the example for drive gear position. It can be a temperature value. It can be a voltage value. Anything else. Yeah, that's all, guys, for the demo. Hope remaining analysis, as I mentioned it, we will see in upcoming videos. I will update this tool and then we can see the service NRC 33 and 78 with the security access and other stuff. Thank you, guys. Thanks for